Uh, can you hear me? Yeah, thank you for the introduction. My name is Lakshman Prasad. I work for McKinsey & Company. McKinsey does management consulting. I work for a division that works with the consultants in order to deliver technology solutions to the end clients. My primary expertise has been in the Python ecosystem and its set of tools, although in the last year I have had to significantly work on JavaScript. I have never done an intro-level talk, particularly on Python, particularly coming after a good session with Peter. I know it can be hard, but when I write such answers about detailed explanations on Stack Overflow, I get a lot of very positive feedback. So that's what I'm trying to do today. Yeah, and by answering many of those questions, I happen to be among the 1.005% of the Stack Overflow users by answering all questions explained, particularly with regards to the basic Python. So I'll try and see what I can do. I had a great time at the conference, by the way. Such a nice city, well organized, such a nice lunch. Since all of you just had lunch, maybe it's a good idea we start with a little bit of warm-up exercise for those of you that know. But don't worry if you don't know the solutions to what we're discussing right now. The objective is at the end of the session, you will be in a position to be able to. So let's say we have a dictionary of states mapped to their capitals. We need a dictionary of states mapped to their capitals. First we have states, and then we also have capitals. Yeah, so if I want a dictionary that maps states to their capitals, how would you get it? You have a list of states and you have a list of capitals. All right, so here is a hint. A zip of states and capitals gives you a tuple of both state as well as capital. So zip is a constructor in Python that takes a stream of pairs, a pair of streams, and gives you a stream of pairs. So if anybody knows, I'm sure you learned a constructor of a dict earlier in Peter's session. So if you pass a dict constructor, a pair of streams, essentially what you get is a dict that gives the states mapped to their corresponding capitals. So similarly, let's go to the next question. We have a list. This is one of the most popular questions. This is coming up so often, being asked by a lot of people on various different channels, particularly Stack Overflow. I have a list of lists. I want to do something on all of these. How do I go about it? What would you do? What are the ways in which you can flatten a list? Or you want to execute something on every element in multiple lists rather than one of them? What would you do? Yes, any solutions? Well, you might have learned it already, but if you don't know, Python supports operator overloading. Therefore, sum in the case of a list is mapped to extending a list. What you do is you take an empty list and then you sum all of the lists. That will give you a list of all of the lists that you're talking about. So those of you that are inclined functionally thinking, who can think about map and reduce, you can, of course, also use map and reduce. Also, there's really no reason you would have to do such a kind of thing, because I think there are several Python alternatives which are imperative. So, but if you want to do it in map and reduce, there are map and reduce solutions. You take a map, you pass each and every list to make it a list, and operator.add is same as doing plus explicitly. So you have 5 plus 4, but you want to do it functionally without explicitly mentioning plus. What would you do? You import the operator module and you say operator.sum, and you apply that on 5 and 4. That's exactly what this is doing. You're mapping and you're doing a map reduce on all of these lists in order to give you a list of lists. This is one other way. And then we will go through a lot of the details about the itertools module. But itertools module supports one important thing called as chain. You have a list of iterables. You take a chain, and to it you pass all the different lists that you have individually. The star supports the star argument. Essentially, gives individual lists, the 4 of them, as arguments into the itertools chain, and then that gives you a list of all of the elements in the list of lists. Similarly, This is a new feature introduced in Python 2.6. Essentially, what you're doing earlier, you're expanding. The itertools, the chain, you're passing 4 different lists as arguments, where that may not be possible. Your list of lists may be continuous. It may be keep going on. So you don't want to expand it individually into so many different things. So Python 2.6 in the itertools module added a new thing called as itertools or chain or from iterable. So you can pass it an iterable. So you don't even have to separate all of these 4 lists into 4 lists like you did elsewhere. But the most obvious, the most Pythonic way of doing it, as long as the list is only 2 levels deep, would be to use a multiple for loop, nested for loop in the form of a list comprehension. So you do for each list in list of lists, for x in each list, give it to me in a list. So that's about it. In fact, you can go multiple levels even using this. Don't worry about it. By the end of the session, my hope is all of you will be in a position to be able to write things like that. So another question, we want to have a product of things. So you have A, B, C, and you have 1, 2. I want to have A1, A2, and then B1, B2, C1, C2. How would you do it? It's easy. I mean, you already know itertools module. You've come across that some places. It's very simple. You just do itertools.product. The point is, itertools module has some of these things that you might want to do. If you ever want to do A, B, C, you have A, B, and 1, 2. And if you ever want A1, B2, and then things like that, expanding, you don't necessarily have to write multiple loops. You can import the things from itertools.product and then just pass 2 lists into it, and then you have all of those expanded. Similarly, let's say now you want a power set of range of values. What is a power set? You have you have 0, 1, 2, 3 are my elements. I want to have everything from null element to 0, 1, 2, 3, including 1, 2, which is a single element, 2 element, 3 element. How do you go about doing it? So again, itertools has another function called as combination. So you pass the combination for NCR. So for 1, 2, give me all possible combinations. Like you see, can give you 0, 1, 0, 2, 1, 2. For 0, 1, 2, for 3C2, these are the various different operations possible. You just loop on the same thing. For each and every possible R, you get the entire power set. So that's about the quick warm-up exercise. But hopefully you will be in a position to do that, like I said. So let's go to the basics of iterations. The reason all of this is possible is because Python has certain abstractions defined for iteration itself at a most basic level, which if you understand and implement in your own programs, well, you can do similar kind of things, implement similar things in your code, which is one of the most important thing. And you also need to leverage what is presented in what is available in the standard library as iterators. So what is a standard for loop? This is a standard for loop, right? Everybody that learns programming, this is the first thing they learn. So you have you keep an integer, and then you loop until the length of an array, until you get a particular element, you do something about it, in this case print, and then you increment the element. This is a standard for standard looping that is taught. The first thing everyone learns, the primary reason this is taught first is because this is the thing that works in all languages, but Python programmers know better than to do that. You don't have to explicitly keep incrementing an integer all the time. Why use an integer? So you could always use something like range. Even range of len is something that is not necessary. You know that we can do for element in a list, print element. So this is what creates, this is what an iterator can do for you. All sequences are iterators. Oops. So let's talk about iterables. So all the sequences, be it characters or a list or a tuple, all of these are iterables. What is an iterator? Iterator, technically, is something that implements 2 things. Those 2 things are iter method as well as the next method. Here, instead of creating similar to an inbuilt list that can loop, I have a class called as fib, which essentially generates Fibonacci series. So in order to make it implementable, so if you're using Fibonacci Fibonacci class, essentially what you would do in your code is for element in fib, then loop over it. So every time the fib is called, the first time it is called, it takes the iter and gives you the 0 and 1, or whatever the corresponding Fibonacci value is. In this case, it happens to give you the same class, but you can also return some other class. But so the next time of Fibonacci, whenever you want a next element, the for loop next is called, and then you get the next element, and the same thing goes on until the stop iteration exception is raised. So this is a fundamental for loop. Essentially in Python, a for loop is something which has two methods, which is iter and next. Iter gives out the element which has, iter gives out to you a particular object which has next, on which next can be run upon. So I said that Python iterators is something that has iter as well as next. We can assume that while that in the case of string, it is an exception. Strings don't have dunder iter method, but still you can loop on because it has get item, but that's technical exception. For our purpose, we could assume anything that has iter as well as next is considered an iterator in Python. And when you call an iter on it, you need to provide an element on which next can be run upon. And each time you run a for loop, for element in this, and next will be called upon the same iterator. And so it is important to differentiate in this case between an iterable and an iterator. An iterable is something that has this method. An iterator is a specific point in that iterator, in that iterable. So same iterable, for example, can have multiple iterators. One of the ways is itertools library has a method called as t, which takes a single iterator and provides you multiple iterators, what you would want to use it for. Maybe if you want to chain certain things, for example, ABC, if I want to get the first element of this and the second element of this, then if I t it, I am able to, since I have two iterators right now, I can get an element from a particular position in this and from a different position in this. Standard library provides many iterators. You see that we saw the state capitals earlier. If I happen to print all of the element in the state capitals, it prints all of them in a particular order. And then it is important to note that dictionary is not necessarily a list kind of data structure. There is no order in a dictionary. A dictionary is a hash table, and it is represented by different keys. But when I try to find out, when I try to print all the elements within the dictionary, I get printed all of the keys in a particular order. This is because the dictionary follows the iterator protocol, and the iterator protocol, the only thing it has to it is to be able to give you a next element. You can't ask it what is the 0th element, what is the 20th element, how am I doing in between these elements. You can't really ask that, although you can using some other things which we'll get into. But the essential quality for an iterator object is just being able to run a next on it. And since the expectation is so limited, you can have iterators implemented on so many different unrelated kinds of things, on everything that can have something of a sequence, on everything that you can have a next element that you want to provide, including dictionaries and your own classes. Similarly, if you don't want keys, if you want to happen to get values, you can also get values. And if you want to get both list keys and values, then a dictionary has something called as items. This gives you a tuple of keys and values. So that's not all about it. The standard library has OS.Walk. OS.Walk takes all of the different files that you have in a particular folder and gives you each and everything. You have to recognize in this case the operating system, file system is a two-dimensional data structure with folders and files. But that doesn't stop us from getting each and every file in a single list. And OS.Walk happens to be one such function that takes a file system path and gives you all of the files in that folder in a nested structure, although it is in a nested structure. And because it is in a nested structure, it gives you a 3-element tuple, which is, I think the first one is the individual folder, the top folder, the second one is the subfolder, and then the name of the file, or something like that. So also, you can do a standard iteration process even on the files. You have to notice, again, in this case, you can't get to a 100th line of a file. You have to read the first 99 in order to get to the 100. But because we have an iterator, we don't have to do read line each and every time. You can just say for line in these lines, give me each and every line. Not just that, because you have these iterables and iterator protocol implemented in all of these places, these can be consumed in so many interesting ways. One of the important example happens to be a list. A list is a method in Python which takes any iterator and then expands it to you. You might have noticed that I have been using list earlier in order to print things. That is because otherwise what it will print is just here you have a generator with a class representation. So if you just cast it into a list, what the list does is goes through each and every element by calling the next on each of them and then gives you what it will be finally. And then not just list, you can give similarly maximum, minimum, and sure. Increase the font of it. I'll try. So it turns out that I'm using reveal.js, and in order to increase the font of this one, I will have to mess with internals right now. Otherwise, it only increases the other things. So. All right, sorry about that. So a standard library also consumes iterators in many places. Like you can do a maximum of any iterator that has numeral values. You can also do a minimum. You can do a sum. It does not have to be a list. It can be any iterator, anything that can give you a next item upon. Similarly, you have a list of iterators. You want to print them. Then you can just join them, and then you will have all of those, join them as a string with a particular string in between, and then you can print that, like I've done here, in order to print all the different letters in a particular word, one line by line, by adding a /n after each one of them. So that's about the iterators in the standard library. We also have, so should you have to write a custom iterator, how would you write one? We already briefly went through that iterator. For writing a Fibonacci iterator, all it takes is writing an iter, as well as implementing a next method on the corresponding class. So if you want to write a custom iterator, let's take, for example, a real-world example where you have a card and you have a deck. A deck has 52 cards of spades, and then, diamonds, heart, and clubs. So when you instantiate a deck, it instantiates itself with all of the cards that you will need. And then the objective is to be able to do for card in a deck and then print everything. You are able to do it in this case because on the deck, in the iter method, I return not the, like I said earlier, you can return something that needs to have a next item upon, and the next has been implemented for a list. And since the deck is only storing all the cards during its initialization in the init, when you try to return, you return the iter, you return the iter method on the self.cards. That gives you a list iterable method. Therefore, I am able to iter through all of these cards one by one. So that's about iterators. There is one specific form of iterators that are of particular interest, which are called as generators. And basically because they are lazy evaluators. One of the whole point of an iterator protocol is that you don't really need to have everything that you want to operate on at once. I need to manipulate on 100,000 things, but I don't need to manipulate on 100,000 things at once. I need to manipulate on one of those things 100 different times, right? So if you want to do that, there is no reason you want to keep all of these elements in memory at the same given time. Since the iterator protocol is so flexible, since you need to give only the next element, you can implement something called as a generator. A generator in its most essential form is something that gives you what is the value that needs to be given out during each execution. Generator, you would write a generator like you would write a function, except instead of writing a return, you include a yield. So what happens? The simplest generator is the one that I've written there. So it is a function. It gives yield 1. When I instantiate it, and then when I execute the next, it gives me the first element. And then when I execute the next again, it gives a stop iteration. So essentially, it follows the it follows the iterator protocol, except it is being lazy. Similarly, I can add yield 1, yield 2, yield 3 in order to give me these values incrementally 1 by 1 and stop the iteration there. Iteratools has a method called as count. And this, when you use count, it provides you an infinite, endless stream of numbers until the value that you have provided. If you provide iteratools.count of 20, it gives you 0 to 19. If you provide iteratools.count of 0, then it provides you an infinite stream of values which you can use. Although if you're using that in a particular method, you have to ensure that there is some way to break out the loop. Otherwise, you will run out of time. So we created something called as we created a card class and a deck class. Let's try to do something with spades. So you want to do something with spades. What is one of the ways you would do it? You create something called as spades, and you loop through each and every card in the deck, and then you find if it is a spade. And if it is a spade, do something about it. But this loop here is doing two different things. One, it is trying to get something that I need to work upon, which happens to be a spade. The second, doing something that I want to do about it. These are two different things. And we can do this separation of concerns. It will be better testable as well. So instead of doing it the way above, we could do it like I have done it below, which is the top, which is it does only the filter of the spade cards. You have created a generator which will loop through each and every card in the deck and provides it to you only if it is a spade. And in the second function, I don't have to bother about whether it is a spade. I can assume that everything that I got is a spade, and then you can do whatever you would want to do. This provides separation of concerns, and then by doing this, in case you have something really large, you will never run out of memory because it does it one by one. This is better programming approach. So generators, while might seem complicated, are not. In fact, can help you making your programs better in so many different cases. So generators can be implemented in multiple ways. One of the simplest ways is instead of writing a list comprehension, you put round brackets instead of the square ones. There, instead of executing all of them at once and providing you a list, it will provide you with a generator object, which you can call next in order to get the next value. And then you can also, like we went through, we can also put it in a function with a yield keyword somewhere at the end or wherever you want in between. So essentially what this does is, for anybody that has written a tree traversing algorithm, anybody that has written tree traversing algorithms knows it's really complicated in order to comprehend the recursions, and there's so many different levels that it has to go through. But if you use a generator, it is so much simpler in order to understand. You give everything that is to my left, you give myself, and then you give everything that is to right. And the way you would do it is you yield that, after that you yield myself, and after that you yield everything to my right. So this is the simplest and the best possible iteration algorithm they can probably write and so easily comprehend. This is so much better than any other form of imperative recursive algorithms that most people have in the image. So if it is a tree, you would not have it as a method. You would instead have it as a method on a particular class. So that's what you have done here. Instead of having it as a function, you have it as a method on a particular class. So that's how you iterate. Obviously, there will be in the tree, in the real-world tree, there will be an initialization function which will take the different lefts, rights, and the positions of each and every node. So similarly, if you have to read a large CSV files, you don't have to stop at a particular, you don't have to, so for example, we're doing it for NASA. NASA wants to find all the people above 6 feet living in DC that have Facebook accounts for whatever the reason that they want. They don't have to, if you include the logic within what you're trying to do, it's not really, like we saw earlier, not really compelling. So instead, you can filter the data that I need as one method, which essentially provides a yield at the end in case of things that you're not interested in, just continue or just discard them. I am only interested in, so what to do upon this, you write as a different function, and then this takes the input values of everything that has been filtered by my earlier decorated function. So similarly with other problems, you have seen many of these code jam problems. They give you, okay, first line has a number of test cases, next line has the number of people and all of that stuff. Using an iterator in order to get those values out is going to be the simplest way. And like we have already discussed about some of the tools that are present in the itertools. Every time you have an iteration problem, there is a solution that someone else wrote out there. Nobody knows everything that is there in itertools. Please feel free to refer to them. One particular point of interest in these itself will be some of these that I consider generator tools. If you have a range of 2 to 5, then you can always do a slice between 2 to 4 because all of these elements already exist in a list. But if you happen to have an X range, which is a generator, you cannot do that because you really don't know what is, because the second to the fifth element aren't really there in the memory at this point in time. But iteratools provides you a method, but it is technically possible in order to get the second to the fifth element by running next 2 times, getting the second element, and then running the next 3 more times in order to get the fifth element, and then discarding everything away, right? So iteratools.islice does exactly that. It implements the slicing for an iterator that is available for an iterator that is available to a generator. Similarly, it has all forms of IMAP and iReduce, etc. Yeah, I encourage you to look it up. This is a very small talk. The summary of this is iterators are very powerful abstractions. You always do iterations, always do iteration. That's one of the fundamental things that you do in a programming. You sit all day, and then you loop things over and over again. So why not do it better? Because if this one thing, by writing iterators better all the time, our programs can become so much better. Iterator module has powerful functions to deal with iterators, and in particular generators. Iterators, like all good programs, make programs better, and most of all, programmers happy. Cool.
Thank you, Lakshman. I'd like to present you with our PyCon coffee from Ritual Coffee in Launceston, and also a PyCon mug.
Thank you.
As we're running a little short on time, do we have 1 or 2 quick questions?
Sorry, just being new to Python, I wasn't quite sure, I think it was slide 3, where you had differences between iter values and values as methods to your object.
Sorry, I didn't follow.
You had iter values and values as 2 different method calls on a list. What's the difference?
So those are not in a list. Those are on a dictionary. Okay. The iter values is a generator thing, which does not necessarily call all of these and then provide to you at once. Values is something that takes all of these values, puts it in a list, and gives it to you in a list.
I was wondering if you could comment a bit more on whether you think it's Pythonic to use more functional methods like the map and reduce functions, and if not, why you think, say, using more generators and list comprehensions is more Pythonic.
So it's funny. So if you see how it is going, most of the time Pythonic people aren't really interested to use something like map or reduce, but they have built a module called as iterators, which are essentially all of the functional aspects within the same thing, and they happen to allow that. So it's just a matter of whether it is appropriate at that particular location. If you find it easier using MapReduce, just go ahead and use it. But most of the time, list comprehension seems natural because that's what we've been used to. I mean, you read a lot of Python code, you get used to doing everything in list comprehension. That's also better because it's faster. Pythonic implementation of list comprehension is often much faster than their corresponding MapReduce counterparts. So it's a balance. You just use it to doing it, and if you just use it to doing something the Pythonic way with list comprehensions, go ahead and do it. But if you see a natural alternative, if it comes to you to do MapReduce, there's nothing stopping you from doing it. But you will gradually move towards doing much more Pythonic way, the more Python you do.
Do we have one more? Well, on behalf of the team, I'd like to thank Lakshman again.
Thank you so much.
If we can all applause.